Hi, this is Alex from devstories.eu. SQLAlchemy, Episode 3 of 7. You write your Python domain models, and then you have to write a separate pile of SQL just to create the tables to hold them. Over time, those two separate definitions almost always drift out of sync. What if your Python classes could automatically design your database schema? That is exactly what we solve today with mapping the domain, DeclarativeBase, and models. Before we look at the classes themselves, we have to talk about database metadata. In SQLAlchemy, metadata is effectively a structural catalog. It is a central Python registry that stores the exact blueprint of your database. It tracks every table, every column, and every constraint you define. Whenever you map a class in SQLAlchemy, the details of that class feed directly into this single catalog. To connect your Python classes to this metadata catalog, you use a construct called DeclarativeBase. You do not use DeclarativeBase directly. Instead, you create your own custom base class by inheriting from it. From that point forward, every single model you build in your application will inherit from your custom base class. The moment a class inherits from it, SQLAlchemy quietly registers that new model into the underlying metadata catalog. Consider how you create a user model. You define a Python class named user and inherit from your custom base class. The first thing you define inside this class is an attribute named TableName, spelled with double underscores on each side. You set this to the string userAccount. This explicit assignment tells SQLAlchemy exactly which underlying database table will store these Python objects. Next, you establish the columns. SQLAlchemy 2.0 relies on standard Python type hints to do this. You define your attributes using a special annotation called mapped. For an identifier, you annotate your ID attribute as mapped containing an integer. For a username, you annotate it as mapped containing a string. This type hint is strictly for Python. It tells your IDE and your type checker what data to expect. But the database engine needs more specific instructions than a simple Python type. This is where a function called mappedColumn comes into play. You assign mappedColumn to your class attribute, and inside its parentheses, you configure the database-specific rules. For your ID, you call mappedColumn and pass a flag that explicitly marks it as the primary key. For a string column, you might pass a maximum character limit or a flag requiring the field to be unique. If your Python type hint provides all the context SQLAlchemy needs, you can actually omit mappedColumn entirely. SQLAlchemy will infer a basic standard database column directly from the mapped annotation. But for primary keys or any specific database constraints, mappedColumn is strictly required. Here is the key insight. Once your Python classes are written, your schema design is already finished. The metadata catalog now contains a perfect map of your domain. You can call a method named createAll on your base class's metadata, passing in your database engine. SQLAlchemy looks at your user class, reads the mapped columns, instantly translates them into perfectly formatted create table statements, and applies them. The exact same Python code you write to run your application becomes the single source of truth that builds your database structure. Thanks for hanging out. Hope you picked up something new.